Okay, we're looking at what's called parameters of sine and cosine functions, and this word parameter refers to letters you might see which get replaced with numbers inside both sine and cosine functions, and in fact these exist in all sorts of functions. A parameter basically is a constant, and you can set it and then forget it. Not really forget it, but you can set it and it will change the nature of the function. It will change the outputs, and it will change the shape. It will change the position, and we're going to look at that in this video. These are important things. They're not the same as the variables. The variables are still x and y, or whatever you've got in your function. Variables change in a normal way as x changes, y changes, but parameters are things that you can set or discover, and then they're fixed for that function. We can see that we've got capital letters A, B, C and D. Now sometimes they're lowercase. It means exactly the same thing. So don't worry too much about whether they're uppercase or lowercase. They get replaced by numbers anyway. And then at the end of this demonstration we're going to have a look at these here. Okay, so there'll be a fair bit to take in this video. Make sure you've got your notes ready and hit pause at any stage. Very important. From the previous video, we remember the shape of sine x, y equals sine x, or y equals sine theta, whatever you're plotting on the x-axis. And you might remember too, cosine is the same shape, but it's been shifted across compared to sine. So that's from the previous video. What we're going to do now is enter in Desmos. We're going to enter A times sine, open brackets, B, open a second set of brackets, x plus c, close brackets twice, and then put a plus d on the end. And it's asking me, do we want to add slider bars? And we do, because that'll allow us to look at what the parameters do. So yes, I want slider bars on all of those, and voila. So you've got now the original function in red for sine x, and then you'll notice that we've got another graph in green there. And the graph in green has had these parameters applied to it. You might be able to see the settings of all of the sliders, and it's changed the graph to some degree there. So what happens there is that the parameters cause cause what's called a transformation, or transformations. So, sorry, my stylus is not behaving. Cause, that word is cause. Transformations. Transformations. Now, transformation can be a translation or dilation. So translation is the position. It changes the position of the graph. It's like a shift, and the dilation is the change of shape. We have two of each, and basically the position ones are caused by the letters C and D, and the dilation is caused by the letters A and B, as we will see. So I'm just going to switch off the original graph here for a moment and look at what A does. Now you might remember that I spoke about amplitude in the previous video, and we can see the effect of A. So if we compare it to the original graph, and I'm just going to set C back to 0. So that's its natural, or its basic state for the core graph, for the basic graph. And if we've got A back to 1, you've got the two graphs on top of each other. If we increase A, it changes the amplitude. Amplitude is the average of the maximum position from up and down. So basically it is the height from its equilibrium or rest position. And so we're going to have a proper look at that a little bit later on. But you can see the effect of A on the front. There's A, and see that it has a vertical stretch, which is that shape change I talked about. So it's not moving the position of the graph. Alright, you can see that it cuts through the x-axis here and here still. It's not moving sideways, it's just stretching it vertically. Alright, the other one that changes the shape is B. So as we increase B, it's compressing the graph. And if we take B back down to 1, which is its regular state, we've got, if it's between 0 and 1, like a fraction, like a half, you can see that it stretches the graph out. So we'll take that back to its rest state, and we'll take that one back to its generic state there too. C moves the graph. Notice there's no shape change there. So it's a movement of position, not shape. And D is also movement of position, vertical translation, not shape. So that's a translation. D is a translation, C is a translation, but B is a shape change, and also A is a shape change. Now these don't have to be positive values. You can make A negative, and look what happens if it's 1 and then we make it -1. It's actually mirrored it in the x-axis, or in its central point of equilibrium. So basically a negative A will flip the graph over. So let's put it back on 1. B compresses it, and you can have negative B values as well. We don't see negative B values very often, to be honest. You're more often to see a negative A value. Also, of course, C, the translation can be positive or negative, which corresponds to a move to the left or the right, and A can be positive or negative, which corresponds with a movement up or down from where it began. What we saw in the video then, and we're going to do some more work on this. This is not the only video on this topic, but basically for A, B, C and D above, whether it's sine or cos, it works in the same way. D is a vertical translation, and if D is positive it moves upwards, if D is negative it moves downwards. This next one needs a bit more work, so on the next video, or one of the next videos, we're going to look at that one more closely. But basically it's about how C moves things to the left and the right. You might see that it's C divided by B. In the next video we're going to have to look at that in more detail, otherwise this video will get too long. B is a horizontal change of scale. Basically that means it compresses it horizontally or stretches it horizontally. So that's if it's a decimal value between 0 and 1, and that will stretch it, and it'll compress it if B is greater than 1. So it might be a bit opposite to what you think, but when B gets bigger than 1 it compresses the graph, so you've got something like that all close together instead of something like that. And if it's negative it's reflected, as we saw, even though that's kind of rare. And A is related to the amplitude and vertical change of scale, so it stretches it vertically once it's above 1, and if it's a decimal, it compresses it. If it's negative, it reflects or inverts it, flips it over. That's the full version of the formulas. They exist in two forms for each sine and cos. We're going to look at that a bit more in the next video, or one of the next videos, because there's a bit more to go yet. And basically too, these are important, and next video we're going to have a look at those important results down there, but they do link to what you saw in this video.